Yeah, so we calculated the electric field due to the dipole at so we calculated the electric field due to dipole at 2 points, right? So one was this axial point. One was this axial point. Where is this point? So we calculated this was electric dipole, right? Electric dipole. And then we calculated that the perpendicular bisector. So this point, this is called the equatorial point. And we calculated at this point, so which was this axial point. Right.
Yes.
Yeah, why is this not working? Did I get disconnected? Okay, what is happening? So what happened? Let me share screen. Yes, so whenever Rabi joins, please tell me. Then we will give you all those questions. Okay.
Yes, sir.
Let me open my one which just abruptly closed. So, yes, are you able to see my screen?
Yes, sir.
It's my right. So then we calculated at this point, which was the axial, right? And due to this point, the field was E plus and E minus. But ultimately it was in this direction. Right, Aisha?
Yes, sir.
And due to this point, this was this was this theta, this was theta, this was theta. So this was theta and this was theta. So this was E minus and this was E plus, right? So then, but ultimately the field was this, right?
Yes.
So this was equatorial. And what is the value that we found? So we found out that E axial was 2 kp and by how much? R square R cube R cube. What was that?
Thank you.
R cube, right? And then we also found out that E equatorial was this was minus of kp by R cube, right?
Yes, sir.
So we see that for the axial case, this was in the direction of this field dipole moment. And for the equatorial case, we saw that this was against the direction of this dipole moment, right?
Yes.
And then we saw that the magnitude of Ex were okay. So please give me one. Yeah, so the magnitude of E axial is how much? This is 2K and P by RK. And the magnitude of equatorial is how much? This is KP by R, right? So we see that when we divide E axial by E equatorial, that would come out to be how much? Hello, Rabi, assalamu alaikum. Hello, Rabia, can you hear us? Right, Aisha.
Yes, sir.
So this I wanted to tell you in the last, but the time ended and okay, now, okay, so let us go back to what we are doing in this class. Yes, yes, Rabia, are you here? Can you hear? Can you hear me? Is your mic not working? Okay, yes, Rabia, can you hear me? Maybe, yeah. So maybe your mic is not because. So did you hear Rabia? Aisha?
No, sir.
Okay, maybe Rabia, maybe check your microphone. So check your mic. Yes. Uh, okay. So if you're not responding, then if you're not able to respond, then this will be problematic because we want to solve all those question term later, right? So yeah, please disconnect your mic and then try to rejoin. So if that helps, right? So try to do that. If you may, please try to do, because I want this class to be today. Yes, still not working. So just remove the microphone and then reconnect, or uh, just log out from the Zoom and then just log in. Two things you try, and then if that not works, so then we will. Okay, yeah. So rejoin, and if that doesn't help, then what we can do, right? Yeah. So yes. Yes, so Aisha, we did the Coulomb's problem, right? So now we can do the Coulomb's question, right? Whatever the kind of Coulomb's question they may ask, we can do that. Right, Aisha?
Yes, sir.
Yes, so now electric field part we need to do. Right, so we were in this electric field part. Yes, Rabia, can you now hear us? Or you can hear
Hello,
us,
sir.
but yes, now you're audible. Right, good. Okay. Yes. So how are you, Rabia? All good.
Fine, sir. Alhamdulillah. How are you?
I'm also good. So Talha is your brother, right?
Yes, sir.
Yeah, yeah. So He is learning maths from me, and he is a very good student, right? So tell him that I was remembering, and tell him that focus on mathematics, not only mathematics, but yeah,
Okay, sir. I'll convey your message.
yeah. Yes, so we were at this point, right? So we learned the symmetric properties of this electric field, right? And we understood that if we calculate the electric field at the geometrical center, right? So that gives the electric field 0, right? So if we calculate the electric field at the geometrical center, then the electric field is 0, right, Ravi and Aisha?
Yes, sir.
Yes, sir.
And that is called the neutral point, right? So that is called the neutral point, right? Okay, and then we know that what is the electric field. So then we also know that the electric field due to point charge is how. So electric field due to point charge. This is E, and this is KQ by R square and R hat. Right, so we can also write it like this. So KQ vector divided by R. Right, guys? So this is the electric field due to a point charge. And we also know that electric field due to multiple charges follow the superposition principle. Right. And then we learned about, so this is multiple charges. And then we also learned about that if we calculate the electric field due to dipole. Right, so electric field due to dipole has two parts. One is the axial one, and the other one is the equatorial one. Right, so Rabia, do you remember what is the electric field due to this axial point, on this axial point? What is that? Yes, Rabia, do you remember what is the electric field of a dipole on the axial point? You forgot or you forgot? This you did in Amna ma'am class, right?
Yes, sir.
Yeah, so please, what you do is that you write all the formulas in some sticky notes and paste it on some boards and daily revise that. Okay, guys. So this is also a suggestion for us. Okay, guys.
Yes, sir.
Yes, sir.
Yeah, this may so uh, the wall will be filled with those sticky notes, but what you get, you need to crack those exams, right? So don't bother. If your parents scold you, then don't take my name, but yeah. So stick all those notes on the wall, right? Yeah, so due to axial point or on the axial point, it is 2 kp by r. Am I right, Aisha?
Yes, sir.
And due to equatorial point, this is minus kp by r. Okay, Rabia. So now do you remember?
Yes, sir.
Yeah, so the axial point is this. Let's say this is minus and this is plus, and this is the axial point, and we are calculating this electric. And at the perpendicular bisector, this is the equatorial point. So the electric field due to this is this in this direction, and electric field due to this axial point is in this direction. This is the direction of the dipole. Right, now you remember, Rabia. all the things?
Yes, sir.
Okay, so let us keep these things in mind and try to do all those questions. Okay, so the first one. A spherical conductor of radius 10 centimeter has a charge of 3 points. So there is a spherical conductor. Right. There is this spherical conductor and whose charge is, so this charge is 3.2 into 10 to the power minus 7 kilo. Okay. And its radius is how much? 10 centimeters. Okay. And we have to calculate. So this charge is uniform, distributed uniformly. So the density or the density, what you call the volumetric density of this charge is same. You have the surface charge density, and then you have this linear charge density, and then you have this volumetric charge density. So this is a conducting sphere, right? So this is a not a shell, this is a sphere. And this has some charge, right? So what is surface charge density? Rabia, can you tell me what is a surface charge density? Yes, Rabia. What is the surface charge density? So when the charge is, yes.
Sir, can you please repeat? Your voice was lagging for me.
Okay, so my voice is not high, lower, or audible, or what? What option is, what is the correct option? Not audible, audible but low, audible but high. Maybe third option is not correct, but between two. So my voice is lagging.
Yes, sir. My
Okay.
internet is quite low today.
Okay, so your internet is unstable. So then yeah. So I was asking that what is the surface charge density? What do you understand about the surface charge density? So as the name suggests, what would be the surface charge density? Yes. As the name suggests that if you have the charges, so let's say this is a plane, right? Then the plane has this surface. So if the charges are accumulated on this surface, let's say plus. So if the charges are accumulated on this surface, so that is called the surface charge density, and this is denoted by sigma. Right. So you must have heard about this infinite sheet. So on this infinite sheet, the charges are on this surface. Right, Rabia? So then you define this, so then you define the surface charge density, which means that charges are divided in some area. Right? Right, Rabia?
Yes, sir.
And if I say linear charge density, so this is some line, or let's say this is some bar, and the charges are divided like this or spread like this, right? So this will have a linear charge density. Right? Aisha, are you getting this point?
Yes, sir.
So linear charge density is represented by this lambda, and this would be how much? Aisha, can you tell me this would be how much?
Anybody?
Q by L, right? So this would be the linear charge density. And if I have this sphere which is filled, right? So this will have a volumetric charge density which is rho, and this is Q by L. Okay, so I just diverted from my initial topic, but just to recap these schematics, right? So Yeah, so I was talking about that these charges are distributed uniformly. So this has a volume charge density which is uniform. Right, it would have been different than the electric field would have been not uniform. Right, so yeah, so the charge density is uniform. Right, and they want us to calculate what is the magnitude of this electric field at a point 15 centimeter. So 15 centimeter is inside this sphere, outside, or on the surface. Where is that? So 15 centimeter is inside the surface, outside the surface, or on the surface. Yeah, so you have a 10 centimeter radius spherical conductor. So 15 centimeter is outside this sphere, inside this sphere, or on this sphere. Where is that? Yes, Rabia, where is that? Very simple question, right?
On the sphere.
On the, so if we want to calculate at 10 centimeter, 10 centimeter is on the sphere, right? Or if I calculate at, let's say, 5 centimeters. So 5 centimeter is inside this sphere. But it is saying that 15 centimeter. So this is 15 centimeter from the center. Right. So this
Yes,
is
sir.
so this is outside the center. Or this is outside this sphere. So whenever this is outside this sphere and this spherical conductor has uniform charge density, so we can assume this charge or this sphere to be a point charge, right? So then we can assume this a point charge. Okay. So then we can assume this as a point charge, and we know that what is the electric field due to a point charge. So when I'll be talking about this Gauss law, so then you can, so from there you can also see that what is the electric field of a sphere outside the sphere, right? So we will see that that is exactly like a point charge. So you have a point charge Q, and this is how much? This is 3.2 into 10 to the power minus 7. And we are calculating the electric field at 15 centimeter at this point. So now tell me, Aisha, what would be the electric field, magnitude of electric field? Yes.
Could you repeat?
Huh?
Could you repeat?
You just calculate the answer also.
No, sir, I'm asking, could you repeat?
Could I repeat? Oh, so I thought that you were saying that could it be B? Oh, yeah. So I am asking that you have a point charge Q, and you are calculating the electric field at some distance R at this point. So what is the electric field of a point charge at some distance? What is the magnitude of the electric? The electric field due to a point charge, right? What is that?
PQ by
Yes.
R squared.
Right. So why are you not confident? Right. So this is, yeah, KQ by R square, right? Due to a point charge, this is KQ by R square. So why are you hesitating? Right? Be confident in your answer. Whether so when I was in BSc, right, and when I was giving some Viva, so when the interviewer or the examiner asked some question and I didn't know the answer, so I just randomly said any answer. I was very confident, right? So don't bother about the right or wrong. So just be confident with the answer, right? Okay.
Yes, sir.
Yeah. So Rabia, is that correct? Yes, Rabia.
Yes, sir.
So this is the electric field due to a point charge, right?
Yeah.
So point charge outside the sphere, we can assume that this to be a point charge. Okay. Okay. You will see from the Gauss theorem that if we have if this is the sphere, right, and this is the Gaussian surface, and if you want to calculate the electric field at this point, so this would be E into 4 pi r square, and this would be K Q. Okay, so this would be Q enclosed by epsilon. So Q enclosed would be Q and rho into 4 pi and this r square, right? So, and then, so you would see that this would come out to be this r square, right? So this would come out to be KQ by r square, right? You will see that. So this we learned about in the Gauss theory. Okay. But just for the time being, in the outside of this sphere, we can just assume to be a point charge. Okay. Yeah, so the electric field of a point charge is this. So this would be how much? This is 9 into 10 to the power 9, and Q is the how much? 3.2 into 10 to the power minus 7. And this is how much? 15 into 15 and into how much? 10 minus 2, 10 minus 2. Okay. So this would be how much then? 9 into 10, 3.2 divided by 25. And this is 10 to the power 9. And this is plus. Okay, so I will ask you guys. So this is minus 7. And this would be what? 10 to the power minus 2, 10 to the power minus 2 would go in upstairs, and this would become how much?
+4.
10 plus 4, so this is plus 4. Right, so this is plus 4, and this would become 3.2 divided by 225, and this is, so 9 plus 4, 13, and this is 6. Okay. So what is this value? 9 point, okay, so let me calculate this. So 9 into 3.2. I am allowed to use the calculator, right? But you guys. Okay, so this is 0.128 into 10 to the power 6. And if I write as 1.28, so that would be how much? That would be how much, guys? So if I write 1.28, so this would be what? 5, 7, or what? Yes.
6.
10 to the power 5 or 7, because this, yeah.
5.
5, right? So this is the answer. Okay, guys.
Yes, sir.
Yeah, so this is the answer. Which one? So A is the answer. Understood, guys? Any doubt? Any doubt in this problem? Rabia and Rabia, any doubt?
No, sir.
Okay. So your Rabia, your response was a hesitant. Right? Do we have any confusion? Because don't keep your confusion within yourself. Are you confusing with the spherical conductor and the point charge? Are you confused about that? Or you understood?
I understood, sir.
Okay, yeah. So yes, then that's it. Yes, so and again we have so we have this question. An electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. Right. So whenever you have, okay, so this question is force due to electric field type. So that I didn't talk. So Rabia, you know about the force in the uniform electric field, right? Force on a charge in uniform electric field. Rabia, you know that, right? Rabia, do you remember? Force on a charge due to electric field. Yes, Rabia. Forgotten or do you remember? Yeah, yes or no. Only two answers are there, right? And Aisha, we have not talked about this force on a charge due to electric field. So let me recap. So let me do that one, right? So let's say you have some electric field, right? And there is some charge over there, Q. This is electric field. Okay, and this is the positive charge, which is kept at here. So we know that force is how much? Force is Q into E. Right, Aisha?
So,
So force on this charge would be in the direction of this, electric field, and that would be QE. So Rabia, now you remember. Rabia, do you
Yes,
remember?
I was about to send it through chat and you wrote the
Okay.
formula.
Okay, yeah, yeah. So yeah, so yes, no worries. And let's say you have an electron, right? So let's say you have an electron which has a negative charge. So for the case of the negative charge, let's say this is the electric field, right? Uniform electric field, and you have a negative charge, let's say minus Q. So electric field is in this direction, but you have the negative charge, so this will be against, the force would be against the direction of this electric field, right? So minus Q. Understood, guys? Oh, Rabia has already did this. So, Aisha, did you understand?
yes.
Yeah. So let's say that you have this electric field. This is the electric field, and one proton is kept here. So what would be the force? What would be the force, and what would be the direction? So this is a proton, right? I am just writing the charge on proton. Okay. Yes, yes, Aisha. Just remember this Q. So this is, let me write it as Q, then you would understand. So this is Q, and the electric field in this direction. So for the positive charge, the force will be in this direction, right?
Yes.
So if I write force, that would be, if this is proton, so this would be E and I hat, right? Understood?
Yes. Yes.
And let's say this is an electron, right? Then force would be in this direction. So minus E. So this would be, F would be, what would be F?
Minus E in.
Right. So this would be, and you see that this is in minus I hat direction, right? Minus I hat
Yes.
direction. Is it clear now?
Yes.
Yeah. So this was about the direction of the force due to, so sorry, Aisha, but we will learn about this in the next class. We are doing currently the dipole, and the next topic is force due to this electric charge. Oh, force in the external electric. Okay, so this was the conceptual part. Rabia has done in her class, but yeah, so we are good. Right, actually. Okay, so an electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. So this is the direction of the electric field, right? An electron is falling from the rest, right? Vertical distance. So electron falls from rest through a vertical distance h. So this is the distance that electron is falling from, right? So what would be the direction of the force?
Obviously.
Yeah, downward, right? Oh,
Mm.
so electron is here, so it would be downward, right?
Yes.
And magnitude would be simply E, right?
Yes, sir.
Yeah. And then the direction of electric field is now reversed. So the direction of the electric field is now reversed. Okay. And now proton is falling. So a proton is falling from this height. So the direction of the force would be this, right? So let's say this is F electron and F proton would be how much? Yes, guys. Q into E, right? And Q is how much? Charge on one proton is how much?
1.6.
Yeah, so that is E, right?
Yes.
So E. So this is the magnitude of the force due to this charge, right?
So
Understood?
for electron, isn't it minus EE?
Yes?
For force on electron, isn't it minus?
Yes, your voice is breaking. Yes, your voice is breaking somehow. Yes, Ash. What did you say? Sorry about that. I couldn't hear. Yes. Hello, Aisha. Your
Yes.
voice still. Can you, Rabia, can you hear Aisha properly?
Yes,
Because
sir.
for me, her voice is breaking. Oh, you can. Oh, my internet is unstable. Sorry, guys. So my internet is unstable. Yeah, can you repeat your question, Aisha?
Uh, isn't it
Hello.
minus E for electron?
Yeah. So you said correctly that this would be Fe would be minus of E. But we are just calculating the magnitude, so we don't bother about this minus sign. Okay.
Okay.
Yeah. So we are just calculating the magnitude, so we don't bother about this minus. Right. Okay, so you can also see that for the proton or for the electron case, the electric field is reversed. So the direction of this electron force and proton force would be the same. So let's say this is minus J. So for this, that would be also minus J. Understood, Aisha?
Yes, sir.
Yeah. So we see that Fe is EE and Fp is EE. Right. So let's say FA and this is EE. Right. Understood, guys? Understood.
Yes, sir.
Yes, guys, understood. Yeah. So A would be how much? This would be E by M. Okay. My internet is
Yes, sir.
unstable. What? Can you guys hear me? Yes,
There is
can you guys hear me?
uh,
Yeah, I think my internet is not still. Let me check. Let me check. Yeah, so am I clear now? Yes, guys, am I clear now? Hello?
So your voice is still
No,
lagging.
still lagging.
Still lagging. Okay, so weather is not good here. Some storm is happening here, and it's raining outside. So I think that may be the cause. So yeah, so is that okay, guys? I'm repeating myself, but can you guys hear me properly?
It's okay, sir.
Yeah. Okay, so this is the acceleration, right? This is the acceleration that will be there for these electron and protons. Okay, understood,
Yes.
guys? So you see that this acceleration is dependent upon this mass, right?
Yes, sir.
Okay, and now what is the use of this h? So what is the initial velocity of electron and proton? What is the initial velocity of electron and proton? Yes, what is the initial velocity of electron and proton?
Next.
0.
Yeah, yeah, see. So what what is the second equation of motion? S is ut plus half at squared. Right.
Yes, sir.
So S is h, u is 0. So we only have half at squared. Right.
Yes, sir.
So we need to find the comparison to the time of fall. So we need to find the time. So from here we can calculate that this is 2h by a, and this is 2t squared. Right, guys?
Yes, sir.
Right. So we see that what is the value of a here? So 2h, and this is e, and this is m. So this is t squared. Right, guys?
Yes,
Yes,
sir.
sir.
Yeah. So this would be, we see that this is 2 is constant, h is constant, e is constant, and electric field is also uniform, which means constant. So t square is directly proportional to m. Okay.
Yes.
So for t would be directly proportional to root m. Right. So if I want to calculate TE, or let's say T of electron and T of proton, so this would be root of M electron by M proton. You two guys understand this part?
Yes, sir.
Yeah. So we know that mass of electron and mass of proton is so which has the greater mass?
Proton.
Proton has the greater mass, right? So this would be this quantity is less than 1 or greater than 1. Right. So this quantity is less than 1 or greater than 1.
Yes, and one.
Less than 1, right? So this is TE by TP would be less than 1, right? So we can say that TE is slower than TP. So electron is slower than photon, right?
Yes.
Understood. So the answer would be small. Understood?
Yes.
Yeah. So please, you guys note down, and then if you guys have any question, you can ask, right? You would have done this by this method also. So we calculated that T square is 2HM by EE. So T is root 2HM by E. So we can calculate TE, which is 2HME by E, and TP, which is also 2HMP by E. So we can calculate TE by TP as all these will cancel, so we'll have ME by ME. So we can use this method also. Right, so this is a longer one, but proportionality is a smaller. So whatever method you guys want to use, you can choose that. Okay.
Yes, sir.
Yeah, so please note down this part, and then we'll do the next question. Where should I keep the screen? Is this okay?
Yes, sir.
Yes, Rabia, did you understand this part?
Yes, sir.
Yeah, whenever you guys have noted down, please tell me, then we can. Rabia got disconnected. So your internet is not, so also your internet is not stable, right, Ravi?
Yes, sir. Sort of.
Yeah, so whenever you guys are finished noting, please tell me then we can discuss the next question.
None, sir.
Then, what about you, Ravi?
Yes, sir. Done.
Okay, so the next question is, okay. So a particle of mass m and charge q is placed at a rest in uniform electric field and then released. The kinetic energy attained by the particle after moving a distance, right? So we know that whenever you hear the name of this, whenever you hear this name of kinetic energy, so you just remember this work energy theorem. Okay, so what is work energy theorem, guys?
For change in kinetic energy is
Yeah,
um,
change in kinetic energy is, this is what, right? So change in kinetic energy is what, right?
yes,
So a particle of mass m and charge q is placed at a rest in uniform electrical field E and then released. So then the kinetic energy attained by this particle after moving a distance y. So change in kinetic, so initial kinetic energy was how much? So initial K initial was half m u square, and u is what?
zero.
Right. So this is 0. And K final, kinetic energy final would be how much? K mv square. Let's say this is K kinetic energy. And this would be, so K F minus K I would be how much? Work done. Work done is how much? So work done, you know that this is Fs. Right, guys?
Yes, sir.
So what is the force in our case? Force is the charge is Q and electric field is E. So force is how much? Right, guys?
Yes, sir.
And what is the distance that it has covered? Right. So what
Your voice speaking.
done would be how much? Q E Y. Right? Yeah. So this would be this. Again, am I audible, guys? Am I clear?
So your
My
voice was
voice is
lagging.
breaking.
Yes, sir.
Okay, so this is a lagging day, I guess, because the weather is not good outside. And I think that okay. So is it? Am I clear now, guys? Am I clear now? Still
Yes,
lagging.
sir.
Am
No,
I
sir, it's
still
clear.
lagging, guys? Oh, yeah. So this is work done. So this is Qy. So kinetic energy is Qey. Any doubt, guys? So this is the answer. Any doubt, guys, in this question?
No, sir.
Yeah. Okay. Again, I see that. Yeah. So you guys, please note it down, and then we. Okay. Please, guys, notice. So whenever you guys are finished, noting this.
None, sir.
Done. What about you, Rabia? Done.
Yes, sir.
Okay, so let us try this question. So a pendulum bob of mass this, right, and carrying a charge q, or carrying a charge this, is at rest in a horizontal uniform electric field, right? The tension in the thread of the pendulum. Okay, so a pendulum of mass is hanging, right? Is hanging with a thread, and let us draw this. So, what is this scenario? So, let's say you have this thread, and some charge is hanging. Okay, and then you have this electric field. So then you have this electric field. Okay, and this electric field is 2000, yeah, 20,000. So this electric field is 20,000 volt per meter. Okay, and we have to calculate the tension in the thread. Okay. Yes, guys. So understood the question.
Yes, sir.
Yes, sir.
So we have to calculate what is the free body diagram of this chart. Okay, so you have this mass, right? So this is the electric field. This is the electric field. So where is the force, guys? Where is the force? On the right, left, up, down. Where is the force?
Down.
Down. Did you say down?
Yes, sir.
Right.
Yes, sir.
Oh, so we just understood that whatever is the direction of the electric field, right? So if you place some charge in here, so this would be in the same direction as, so the force would be in the same direction as this electric field, right? So the force would be in this direction, as Aisha was saying in the right? So the force is in this direction, right?
Yes, sir.
And this q is so this is some mass, this has some mass, right? This has some mass, so this would be, so what is the another force that is acting on this mass? Due to mass, what is the force that acts on this mass? Yes, guys. So due to the mass, what is the force that acts on this? So let's say this has some mass. So what would be the force that is acting on this mass? Yeah, yes,
Coulomb force.
yeah, the weight, the downward. What you're saying this?
No, sir.
Oh, so you were saying the upward force,
I said Coulomb force.
Coulomb force. No, because there's no 2-point charges, right? There is the force due to this electric field. There is this force due to this electric field, and which is in this direction. You already calculated it. So this was the electric field, right? And in this electric field, you had some charges. So we calculated the force on this charge due to this electric field, and this was this, right, which was QE. You remember, Aisha?
Yes.
So this is F, which is QE, right? And this is weight. So you see that this is downward, this is in this direction. So what would be the resultant? What would be the resultant force? Where would be the resultant force? Yes, we got disconnected. Yeah. So where is the resultant force, Aisha?
So could you repeat again?
Yeah. So you have this force which is acting in this direction. Let's say F1. We have this force which is acting in this direction. So these are two vectorial forces. So what would be the resultant force, Aisha?
F1 square plus F2 square.
So this, yeah. So this would be the resultant force, right?
Yes.
So this is the resultant force that is acting on this. Yes, Rabia. Again, got disconnected. Hello, Rabia. Can
Yes,
you?
sir.
Yeah. So I am asking that the two forces are acting in this direction and in this direction, right? So what would be the resultant force? We know. This is the resultant force, right? You guys
Yes, sir.
forgot, yeah, you guys forgot about the vector part. So let's say you have this vector and this vector. So from the parallelograms law, let's say we draw some parallel line here, we draw some parallel line here. Right. So the resultant would be this. Right, guys? If the vectors are perpendicular, so what is the resultant? Yeah, guys. So if vectors are perpendicular, say this is F1, this is F2. So what would be this F? Confused, guys? Yes, what happened, guys? Vector classes, you guys forgot. Okay. So let me again. So just remember this diagram, right? Just remember this diagram that you have two perpendicular forces. And let me repeat. So this is, so this is one vector A, this is one vector B, right? And this is perpendicular. So we know that the resultant would be this, and the magnitude of this resultant would be, this is theta, right? So the magnitude of the resultant is A square plus B square plus how much? Yes, Aisha, what is this value?
2B cos.
2AB cos theta. Yeah, you guys remember now. And what is cos theta here? Theta is 90, right? So cos
Yeah.
9, yeah, so cos 90 is 0, so this cancels. And we have only A square plus B square. Right. So whenever you have two perpendicular, the resultant would be this, and this resultant would be root of F square. So let's say this is due to charge, right? Let's say Q. And this is mg square. Okay, so this would be QE square plus mg square. This is the force that is acting on this charge. Understood, guys? So
Yes.
this is the force, and what is balancing this force? What is balancing this force? Tension, right? So this is the tension that is balancing the force. So this is equal. So the tension is equal to root of QE square plus mg square. Do you understand now, guys? Oh, we have to find the value of this tension. So, do you guys understand this part?
Yes,
Yes.
sir.
Yeah, so let us calculate what would be the value of this tension. So, are you guys tired today or what? You guys are, so your energy seems to be very low. What is happening? Weather is not good and you guys are tired or what? Yes, guys. Feeling not well.
Just a little sleepy.
Yeah, sleepy. So what's the time there? It's 7 or what? It's
7:30.
what 7:30.
Yes.
Yes,
So at 7:30 you guys feel sleepy. What is happening with you guys?
sir. I've been awake since morning.
Oh
Early.
yeah,
We had school, right?
yeah, okay, yeah. So you guys are awake from the 5 p.m. right? Okay. So I sleep at 1 or 2 o'clock. So my sleeping cycle is a bit different. Your so you guys so have a different sleeping cycle. So you guys wake up at 5 a.m. in the morning, 5 or 4, 4 or 5.
4:35.
4,
6
okay.
for me.
Yeah, so 4 and 5, and then yeah, so that's why you guys feel so tired. Yeah, so this is such is life, right, guys? So this is 12th class, and after that, we have to join some college, right? So this is a very crucial time, and we have to do some sacrifice, right? So we have to make some sacrifices, right, guys?
Yes,
Yeah.
sir.
Yeah, yeah. So there's nothing that we can do. So whenever you guys, so just remember these sacrifices, right? And whenever you join, inshallah, some good college, then just what take the revenge of this sacrifice, right? So enjoy your life to the fullest when you guys reach to some good college, inshallah. Okay.
Yes, sir. Thank you.
Thank
Yeah.
you, sir.
Yes. So now let us focus on. So this is. So we are stuck at this question, right? So so you guys understood. So this was the resultant force, right? And this is due to this charge being in equilibrium. So this is balanced by this force. And so this is the tension. Okay. And we have to calculate this tension. So yeah, so this is another kind of tension that we have to calculate. So E is 20,000. Let us write these values at some point. So E is 20,000, G is 9.8, and what is the rest one? So charge is 2 into 10 to the power minus 8, and mass is 30.7 into 10 to the power minus 6. Okay, so these are some huge numbers. So T would be charge is 2 into 10 to the power minus 8, and into this is E, so E is 20,000 and square of that plus MGM is 30.7 into 10 to the power minus 6 into 9.8 and then square of that. Okay, so this is, yeah, so 1, 2, 3, 4. So 4 into 10 to the power minus 4 square, and this is 30.7 and 9.8. So this is how much. Okay, so this we need to calculate. So what will I, so 30.7 into 9.8. So 300 300.86 into 10 to the power minus 6 and square. Right, so this is nearly 3. Okay, so this is 4 into 10 to the power minus 4 square, and this is nearly 3 into 10 to the power minus 4 square. Right, so I am just approximating these values. So 10 to the power minus 4 square is common. So this would be 10 to the power minus 4 in the outside. This is 4 square plus 3 square. So this is 5 into 10 to the power minus 4 approximately. Right, so just, yeah, so approximately this value. Yeah, so did you guys understood this part?
Yes, sir.
And why did I approximated this as, so you see that this is 10 to the power 2 here, right? 10 to the power 2 minus 6 is minus 4. Right, guys? And this is 3. So I neglected this 8, 6. So this is 3 and this is 4. Understood, guys?
Yes, sir.
Yeah, so just note this down and then okay, guys. So today, just because Rabia is feeling sleepy, so today I'll stop at here. Okay,
Yes, sir.
Thank you,
just
sir.
for, yeah, just for today, right?
Thank you.
Yeah. So please note down this question, and then I will give you guys some question I will give, and you guys try those questions. This force is equal to because force is balancing the tension. Now, whenever you guys are finished with this, then I will scroll down this question.
Done,
Done.
sir.
Yeah, you guys are in sync. Done, guys.
Yes, sir.
Yes, sir.
Okay, so just take these two questions. Right, just take these two questions. Okay, so okay, so just take the screenshot of these two questions as well. Right. This one is infinite charge. So you have, let me give you a hint of this question. So you have this question, this charge, right? So this charge is at 1 meter. One charge is at 1 meter, then another charge at 2 meter, then another at 3, and then this goes as 2 at infinity, right? And at the origin, they want us to calculate the electric. Okay. Right, guys? So infinite charges of magnitude q each. So this is q again. This is q, this is q, this is q, this is q. The magnitude of charges are same. Q, 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 and q, q. Right. Understood, guys?
Yes, sir.
So what is the electric field due to this charge? That would be kq by x squared. Right, let's say E1. Okay.
Yes, sir.
So E1 would be 1 square, E2 would be kq by 2 square, right? And this E3 is kq by 4 square, right? And then you have this E, let's say n, which is kq by n square. So this is how it goes. And you have to calculate the total electric field. That would be, so this is on the same axis. So the direction of all the electric field is same. So you can just add. So E would be kq1 square, kq2 square, kq4 square, right? So kq8 square. So you guys find out what would be. Let me give you just one hint that you have to use geometric progression. Right, geometric progression you guys need to use, and that is a by 1 minus r. So this is the total question. So this is the whole idea that you need to solve this question. Understood, guys?
Yes, sir.
So take this as your homework, and this you can calculate. Right, so calculate, we have to calculate direction of the electric field. So just calculate the electric field at this point. Okay. Okay, guys, so see you in the next week. You have 1 week to solve this problem. So please, guys,